So now what we're going to do is we're going to take a look at probabilities and how we can represent them visually in terms of a Venn diagram. So let's go ahead and jump right in. So let's say a teacher asks how many of their students study chemistry, and then find the number, biology, same thing. But she remembers that there's 26 students in the class. So if 15 people said chemistry, 13 people said biology, there's 28 people. What's going on? Well, how can we go about representing this data visually and see if there is a miscounting error? Well, let's think about this. Did we ask ourselves how many people study both biology and chemistry, or how many people just study chemistry but not biology? So let's go ahead and call one of these circles to represent the population of kids taking biology, and this would be the population of kids taking chemistry. And in the middle is going to be both. We never took into account the fact that there was both. Okay? Now, we also know that there are 5 of the students that don't take any of them. And what we do is we put that outside of the circles to denote that they are not involved in any of those 2 classes. So we have 15 people that study chemistry, meaning that the entire chemistry circle must be 15. So this must be 15 minus x, because if x is right here, 15 minus x is right here, well then 15 minus x plus x would give you just 15, represent the total number of kids in chemistry. Same thing over in biology, we would have 13 minus x. So what does that all mean? Well, it means that the total kids taking biology, which is 13 minus x, plus the number of kids taking both, plus the number of kids taking just chemistry, plus the number of kids that aren't doing anything, must be equal to 26. So I have negative x plus x, that's going to cancel, then I have minus x, so I'm going to have 28 minus x plus 5 equals 26. So that means that I can now have 28 plus 5, that's going to be 33 minus x equals 26. Go ahead and move the x over, go ahead and move the 26 over. What that means is that x is equal to 7. So how many people study both biology and chemistry? Well, that's going to be my middle one, 7 for my Venn diagram, as people study both. Now, if I have 13 minus x for biology, that means that I would have 13 minus 7. So biology would be 13 minus 7. That's going to give me a grand total of 6. For chemistry, I have 15 minus 7. It's going to give me a grand total of 8. So that's how many kids would be in for those categories. Now, so let's say, let's take another example. Let's say in a class of 29 students, I have 19 people that study German, 14 that study Hindi, and 5 that study both. How many kids study neither? So I have 29 total students. So let's say I have a Germany one here and a Hindi one here. And I know that 5 study both languages, and it's always really helpful to start here because I'm going to have 5. Now, the most common mistake that I see students make is that they'll put 19 in for studying German. This isn't true because 19 kids in total study German, and 5 of them happen to study Hindi, which means that this area right here, which is German and only German, must actually be 19 minus 5, which would give me 14. So that way I would have 14 and 5, 19 in total for German. For Hindi, I have 14, so I would have 9 that study Hindi and only Hindi, as well as the 5 that study both. Now, how many people don't study either? Well, I know that I have 14 plus 5 plus 9. That's going to give me 23 plus 5. That's going to give me 28. Well, I have 29 total students. That means that one person must not study either of them to get me to my total population size. Now let's take a look at just one last example to really bring the point home. So let's say that in a class of 26 students, it is found that 10 study geography, 16 study history, and 4 study neither of them. Okay, so right off the bat, I know that I'm going to have geography and history. Let's calculate the number of students who study both history and geography. So I know that I have 4 that study neither of them. That goes on the outside of the box. I have 26 total students. So what's really helpful in these kind of examples, when you don't know how many people studied in the middle, that studied both of something, denote that by X. Because I know that 10 people study geography in total, meaning that geography and only geography with no overlap with history must be 10 minus X, which means that this would be 16 minus X. Okay? And what I know from that is that if I had 10 minus X, the kids who study geography and only geography, plus the ones that study both, plus 16 minus X, the ones that study history and only history, plus the 4 that study neither, that must be equal to my 26 total students. So what does that mean? Well, I'm going to have 10, 16, and 4. That's going to give me not the 20, that's going to give me 30. Negative x plus x, that cancels. Then I have one more minus x is equal to 26. So 4 equals x. So 4 students study both. So you create the diagram, do the algebra, solve for your missing variable. Now what I want to do is find the probability that a student selected at random from the class studies exactly one of these subjects. So what might actually help is that if I know that x is equal to 4, well then what that means is that 10 minus 4 is going to be 6. That's the number of students that study geography and only geography. Then I have the 4 that study both. Then I have 16 minus 4 for history, which is going to give me 12. Okay, so what's the probability that a student selected at random from this class studies exactly one of these subjects? Well, I have 6 that study geography and 12 that study history in isolation, which gives me a grand total of 18. And how many students do I have in the class? I have 26. So 18 out of the 26 students satisfy my criteria. Now, it depends on how you want to answer this. You could put this as 9 over 13 as a simplified fraction, or you can go ahead and put that in your calculator and get a decimal, which is going to be 0.692 or 69.2%. Either way, one of these answers will suffice. It depends on what the context of the problem asks you or if it asks for it explicitly. So that's how you go about creating Venn diagrams. Always start in the middle. Remember that the people that don't apply or that are not taken into consideration for either of the subjects are going to be placed on the outside of the Venn diagram, and then just set up an algebraic equation and solve for the missing variable. See you all in the next video.